Hi there, I'm Tanya VanOrden. I teach both 7th and 8th grade science at Islander Middle School. And this curriculum overview video is just intended to give you a little bit of a sense of my teaching philosophy, how to support your child in learning science, and how we can communicate between the two of us. So I'm going to try to go into screen sharing here. And that's not where I meant to start. I meant to start way back here with that introductory slide. And then leap to this sort of image, which just never ceases to inspire me as far as hands-on learning and nurturing plants in real life, nurturing students in real life. Even the soil, the hand that is in that image, are all things that I like our 7th and 8th grade science curriculum to touch on. I strongly believe that we learn science by doing science, and I strongly believe in being, skipped over a couple there, a lifelong learner, and I model that with students a lot. I do a lot of lifelong learning in the summers with conferences and trips to Montana, and just really value meeting science teachers from all over the country and sharing that with kids. I am also a huge fan of Atul Gawande's work and taking control of our time management and pre-planning both just the to-do list, like might show up on a calendar, but also pre-planning the action steps, like asking questions and time to communicate with the teacher. Schoology is the best tool for doing that. And I like to post things at the beginning of the week and commit to that with students and put things into calendar view like this so that they can see it and plan. And then they can also, like I said, use this as the messaging center to ask questions with me or let me know where they are in their thinking. So I consider all of that proactive. Whereas the next 4 slides are more after the fact and reactive as far as what you see when I communicate something in Skyward. And I apologize, these next couple slides are wordy, but it's my best chance to get some of these ideas out. And then I will also include the things towards the bottom of this slide in our course policies and procedures. Your students will hear the term proficiency scale a lot. That is the tool when something is at the point or official enough to get a grade mark, a 1, 2, 3, or 4, where a 3 is at standard. And if we are obtaining, evaluating, and communicating information or engaging in argument from evidence, for example, say we have a reading and then students are making a claim and supporting that claim from reading, I'll abbreviate that OEAC. That's 2 large skill areas in science. There are 4 large skill areas in science where we continue to grow throughout middle school, high school, college, adulthood. These are really the experimental ones when we're doing a lab or an experiment. Sometimes I will emphasize the data collection. Sometimes I will emphasize students coming up with their own question. Other times I will emphasize the presentation and the analysis of the data itself. I'll use IMAD for those 4. And then I will use MES, like a mess, for developing and using models or constructing explanations and designing solutions. And these are the times in science when we are making the unobservable observable, like cell models, trying to use a diagram to show how genetics works, the solar system, energy moving through a system. Those are those 2. Okay, so like I said, 8 big areas, 3 codes. And then just overall, communication and curiosity would really be my 2 takeaways, both students communicating directly with me, and you are welcome to communicate with me. Also, I consider you a valuable partner. And like I said, really just trying to look at those skill areas and lifelong curiosity and lifelong learning. Thank you.